Alrighty, y'all. Today we're taking a look at homework 4, question 8. And I know he said in class that we're not going to be going over the force on a wire, current and wire, but this one's kind of straightforward, so I thought I'd just talk through it based on what I read in the textbook. All right, so we have a current loop with a current of 3 amps, a radius of 5 centimeters. It's immersed in a magnetic field confined to the square region, which has a magnitude of that, the force on the current loop. So what we can do is, in general, right, our magnetic force, if it's not just on a point charge, we can do like what we've always done with the same thing like we were doing with fields and stuff, where we can integrate over our surface. And so the integral of I b r sine theta, or sine theta, we'll call it d alpha, right? Because it's going to go all the way around. So our alpha, that's going to be alpha. Usually I'd use a theta, but I don't want to get confused with this theta, because that's our angle in between our magnetic field and our current, right? So sine theta I can just get rid of, because we know that since our current is going parallel to our paper and our magnetic field is going into the paper, they're going to be at a 90-degree angle. So we have sine of 90. Sine of 90 is just 1, so we can get rid of that. So we're integrating, and we're integrating from 0 to pi, or 0 to 2 pi, because we're going all the way around the circle. I, b, r, d alpha, right? So the fun part about this, actually, right, because this is for magnitude of a force. That's the equations for magnitude. But we have magnitude and direction in our fun little example. All right, so if we're over here at this point, our magnetic force is going to be in a direction. Let's just say it's this direction, hypothetically. If we're over here, it's going to be in this direction. All right, so as we go all the way around at all these different points, there's always going to be an opposite one acting opposite, right? So if we sum all these together, right, it's the same thing about when we were finding symmetries of our electric field. Our total net, the total net force on the current loop is going to be 0, because it's totally immersed. That's going to give us our 0 newtons. All right. Well, I hope you find this video just a little bit helpful. If you have any questions on this, or if you have another problem that you want me to try to explain, let me know, and I will do my best to explain it, because I guess Sydney explains stuff.